Hello folks, Mr. G here. We are continuing with number patterns this week, and I just thought maybe before we wrap up, it would be proper to take a deep dive into this topic, guys. Meaning we're going to do some complex procedure thinking questions, and so it will be a good exposure for you, I believe, and I hope you do enjoy it. Let's see here what have we got. Given the quadratic number pattern, a negative 20, a negative 9, 0, 7, moving on, we have to find Tn. For me, the interesting question really is this one here. Which term of the pattern rather will have the highest value? Okay, that's a very interesting application question. So let's go for this. We know it's a quadratic question, so pattern. We're going to have a first and a second difference. So we're going to go ahead here and see what is a negative 9 minus a negative 20. Very, very important there that you don't lose this. This is 11. I'm telling you, I can promise you, once you don't get this right, you are gone. You must get used to this. If it means writing it down, please do that so that you punch the correct thing in the calculator. And I'm emphasizing this once again because I've seen folks do a negative 9, then as they say a negative 20, and they get a negative 29. Guess what? Already you have lost the battle. So please get used to substituting correctly when you work with complex procedures like this. And of course, again, here we've got a 0. Maybe I should write this so that you get used to it. You've got a 0 minus a negative 9. You can see now we're going to get a plus there. Once again, you've got a 7 minus a 0. I guess that one is pretty obvious, and we can see the linear pattern coming up here, and we can see then that the difference really here, 9 minus 11 is a negative 2, 7 minus 9 is also a negative 2. So there we are, negative 2, 2a is a negative 2, therefore a is a negative 1. So as we formulate Tn, we know we're going to have negative n squared. Now we must find b and c, and of course, business as usual here, 3a plus b is equal to 11. We know a is a negative 1, taking negative 3 that side, so b will be a 14. So we're going to add a 14n there. And finally, we know that a plus b plus c will be term 1, which is a negative 20 in this case. And so we have found a to be a negative 1 already. B is a 14 plus c, which is a negative 20. So what we have here is actually a 13. But now it's going to the other side is going to be a negative. So C is actually negative 33. But of course, we will not just quickly conclude on this. We're going to put this to the test. Let's take randomly term 2 and maybe term 4 and see if this works. So I'm going to go ahead here in my calculator and start with a negative sign. And guess what? I am actually opening a bracket in my calculator. I'm going to say 2 close bracket, all squared, plus 14 open bracket 2 minus a 33, and I get a negative 9 as expected. Then I'm going to jump. Maybe I can, instead of jumping, I can take all this. Then I just substitute. I get a 0 for 3. And then for term 4, let us see what will I get. I'm expecting a 7, and that's exactly what I get. You can go ahead and check for term 1, and I also get a negative 20. So this is very perfect. Okay. Now, the interesting part is this one here. Which term of the pattern will have the highest value? Now, guys, when I introduced this, I said to you, remember the linear function corresponds to the linear sequence. In the same way, the quadratic function corresponds to the quadratic number pattern. In essence, we must actually think of this as a parabola. And if you can think about this, if f of x is minus x squared plus x plus maybe 2, in fact, let me write this as a resemblance of a function minus x squared plus 14x minus 33. If you were to sketch this function, as a matter of fact, you would have a set face. And that is why this question is talking about the highest value because you do have a maximum point on a parabola with a negative a. So what we've got to do really is to go ahead and find the coordinates of the turning point. And of course, you have two ways. You can either complete the square and have this written in the form Tn, in the form where f of x is actually of the form ax minus p all squared plus q. Then you know p and q are your turning point. But otherwise, we can use this fact that x, for the axis of symmetry, the x coordinate is minus b over 2a. And what is our b in this case? 14. And then a is a negative 1. And we can see here, we're going to have 14 over 2, which is a 7. So actually, term 7, this is the x value, which corresponds to the n value as a matter of fact. So x, remember, is the same as n here, and this is 7. So T7 should actually have the highest value. And if we were to find that value, of course, you're just going to substitute your 7 there into the original equation, and that will give you actually a 16. So a 16 is the highest value. That means the other terms after term 7 should actually be low. And let's see if that is the case. You can take term 8 and substitute into this. You will see it's a 15. Let's take term 15 also and see if really we will get a value less than 16. Absolutely, we actually get a negative 48. So you can see indeed term number 7 will be the term that has the highest value. So a very interesting way to actually see how functions link up with patterns. Cheers.